Okay, solve the system of equations. First, we're going to write the system in row echelon form, and then we're going to back substitute. Looks like the easiest way to start will be right here with this equation 2. If I move that up to the equation 1 position and multiply through by -1, we'll have a positive x term. So let me do that. It's going to be x minus 2y equals 4. Then my new equation 2 is going to be 2x minus y plus 3z equals 8. And then equation 3 is going to be 4x minus 2y plus 6z equals 16. Okay, so now I want to get rid of the x term in equation 2. Looks like if I multiply equation 1 by -2 and then add it to equation 2, that'll get rid of this 2x down here. So let's do that. So my equation 1 is still going to be x minus 2y equals 4. So -2 times x is -2x plus 2x is 0, so there's nothing for the x term for equation 2. -2 times -2y is 4y, minus y is 3y. And then -2 times 0 is 0, so we just put the plus 3z that was already at equation 2. -2 times 4 is -8, plus 8 equals 0. And then this equation 3, as I'm recopying it, I'm noticing that all these terms can be divided by 2. So I'm just going to go ahead and do that. So equation 3 multiplied by 1/2 or divided by 2 is going to be 2x minus y plus 3z equals 8. Now I want to make this leading coefficient for the y at 1, so I'm going to multiply through by 1/3 or divide by 3 for equation 2. So recopy those. It's going to be x minus 2y equals 4, and then y plus z equals 0. And then the equation 3 is going to be the same still, 2x minus y plus 3z equals 8. Once again, I multiplied equation 2 by 1/3 or divided by 3, however you want to look at it. So now I want to get rid of this 2x for equation 3, multiply through by -2 times equation 1, and then add. So let me recopy. Equation 1 will be the same, x minus 2y equals 4. Equation 2 will be the same, y plus z equals 0. Equation 3 will be, let's see, -2 times x is -2x, plus 2x is 0, so the x term is not there. -2 times -2y is 4y, and then minus y is 3y. And then 0 for z, so you simply have the plus 3z. And then 4 times -2 is -8, plus 8 is 0. Okay, so next thing I want to do is I want to get rid of this y term here, so I'm going to multiply through by -3 times equation 2 and then add it to equation 3. X minus 2y equals 4 is still the equation 1. Equation 2 doesn't change either, it's y plus z equals 0. -3 times y is -3y, plus 3y is 0, so there's no y term. -3 times z is -3z, plus 3z is 0, so there's no z term. And then -3 times 0 is 0, plus 0 equals 0. So we have 0 here, and I have a 0 on this side because the x, y, and z terms are all 0. Okay, now this is an interesting situation. This means that there is a consistent dependent situation. In other words, the solution is not a single point. There are going to be multiple points and probably a line. So what we need to do is we need to find a way to write that solution space. Well, what I'm going to do, since the z term is missing here, 0 equals 0, I'm just going to let a variable a equals z. And so this a is used to write a relationship with the other variables, and you'll see how that works. So I'm going to take the a and back substitute for z in here. So it's going to be for equation 2, y plus a equals 0. Subtract a, y equals -a. Okay? And then for the x, I'm going to put this negative a in for y and then solve for the x in terms of a. So x minus 2 times negative a equals 4. Simplify and continue by going up top here. X plus 2a equals 4. So x equals 4 minus 2a. All right, so now we have all the variables in terms of a, and here's how you write it. You could write 4 minus 2a, comma, and then y was negative a, and then z is just a. You can write it just like that. Okay, so this is a way to express the line that represents the system of equations. So basically how it works is you pick a number for z. Say you pick 1. Then you can use the solution space here to find the x and y values that match for the solution of 1. So for example, one solution would be 4 minus 2 times 1, comma, negative 1, comma 1, if we just use a 1 for z. And that would simplify to, see, 4 minus 2 times 1, that's just going to be 2, negative 1, 1. So that's one point that would be on the line. What if we have a equals 0? Well, negative a would be 0, and then 4 minus 2a would simply be 4. So 4, 0, 0. That's another point on the line. So you can continue, pick any a value, and then you can find the point that would be on the line for the solution for the system of equations. So that's what this means. 4 minus 2a, comma, negative a, comma, a, that represents a line. And then by picking values for a, you can find points that fit as a solution of the system of equations.